All right, guys, we're going on to 8.2, which is testing a claim about proportion. So we're going to be sticking with, remember, P and P hat. One is population proportion, one is sample proportion. So the last section was all about just vocab and type 1 and type 2 errors and what kind of values we are, one-tailed, two-tailed, a z-test or a t-test. Now we're going to focus more on like doing examples, which I'm pretty sure you guys are going to be happy about. So part 1 says a normal approximation method. So I'm actually going to do both methods at the same time. Figure that would be a lot easier than just do one method and go back and do the other method. So it says the following information is used for testing a claim about a population proportion, and it's only about proportions, by using a normal distribution as an approximate to a binomial distribution. So we're going to focus on normal distribution essentially, and the nice thing is you already know how to do that. Okay, so here's some notations you guys need to know. So what does n stand for? If you remember, that's your sample size. I was going to write n equals n. That's your sample size. What does x equal? X is the number of people that say yes. So number of people that say yes or that say yes. Or it's like the number of people you're looking at from the part. What is your P hat? Remember, your P hat is your sample proportion. Sample proportion. That's also a way to find it is your x over your n. So if I have 15 people I'm looking at and 7 of them say yes, 7 over 15, and you convert that to a decimal, that's your P hat. Okay. And then what's your P stand for? Your P is your population proportion. And then we're going to use our P value. And that is the probability, so the probability of your, well, I'm not going to get into technical terms, but it's your probability of the problem. We'll go more into that a little bit later. It's not a proportion, it's a probability. It's a percentage usually. And just a little heads up, what's your Q? That's 1 minus pure P. Okay, some requirements. So the first one you guys know and you guys love, it's your SRS. And your second requirement is NP is greater or equal to 5. And what was the other one? NQ is greater or equal to 5. Okay, and here's a little note I want you guys to do. If it's not true, now if you remember your homework problem said if it's not true, just say it's not true and you stop. But for this one, even if it's not true, still solve. Still solve the problem. And say not reliable. And say not reliable. And we will do an example of this, I think at the end of the notes of this chapter and the next section. Okay, now the ones you don't have to do, I'm going to write keep in mind. But this is the one you have to keep in mind. It's your bins. And I'm not going to write everything out, but it's just keep your bins. Remember, if it's binomial, so probability of failure in your results, they're all independent. It's a fixed number of trials, and you have the probability of success remains the same throughout. All right, so if you're doing this by hand, okay, I'm going to write this by hand. So I'm just going to write hand and calc, and I'm going to just shorten those up because I don't want to keep writing calc in hand every single time. So if it's a proportion, what kind of test do? We do a z-test, all right? So if you're doing this by hand, you're going to use this formula. The first step you're going to do is you're going to do P hat minus P over the square root of PQ over N, okay? I wrote this out in a chart, in 8.1. So I wrote this out. We're only looking at proportions. So we're only looking at the part across from it, okay? And then what you do is then use normal CDF, okay? That's if you're doing this by hand. Again, I'm going to do it both ways. If you're doing it by calculator, you're going to use the one prop z-test. And how do you get to the test? If you remember, you hit stat, tests, and then I'm trying to think about what number it is. It's number 5, one prop z-test. Okay, again, if you're doing this by calculator, what's different than it by hand? If you're doing it by calculator, you have to list out all variables. Okay, for this one, you use normal CDF, and then you're going to get your p-value. For this one, you're going to list out all the variables, which includes your p-value. Okay, so are you guys ready for an example? That sounds like it's a yes. All right, so let's go ahead and do an example. It's pretty much the same thing over and over again. And I think that's a good thing for you guys. So let's go and try it out. So it says the chapter problem cited at Pitney Bowes survey, which 1,009 consumers were asked if they were comfortable with having drones deliver their purchases. And 54%, or 545 of them, responded with no. Use these results to test the claim that the most consumers are uncomfortable with drone deliveries. We interpret most to mean more than half or greater than 0.5. We actually did this exact problem in our last notes, so a kind of a good practice problem if you guys wanted to try it out, but we're gonna do it all together now, like every single part. So the first thing you have to do is your state. Okay, so we're gonna do state, plan, do, conclude. And I'm gonna write state here. And I'm gonna write pretty small, so I know if it's a little hard to read, you're gonna have to go ahead and like look at the answer key that I'm gonna post. So state, so we're gonna and this is proportions because it's talking about proportions. And that's like, we know that already because it's the same problem. So we're gonna let P equal, and what does P stand for? It stands for proportion of consumers who are uncomfortable with drone deliveries. Okay, all right, so that's our state. Okay, we're gonna go ahead and write out our ho and our ha. Before we do that though, I'm gonna go ahead and write some important information out. So this right here is how many people we looked at. So what variable that is it? That's our N. Our 54% is how many people said yes. So we're gonna say that's our P hat, which is 0.54. Our 545 people are our X value because that's how many people said no. And we're saying no in terms of are you comfortable or not, and we're saying no. And then the one number we're missing is more than half. So our more than half is going to be our P value is 0.5. And then we're like, wait a second, I actually didn't tell you what significance level to give you. And if I don't tell you, and you did write this down, if I don't tell you, we're gonna use alpha of 0.05. And that's just always the case. Okay, and those are all our variables. Again, that's not part of the problem. It just makes your problem a lot easier. Okay, so so our state, we're gonna go ahead and state our ho and our ha as well. So our ho is our P is 0.5. Remember, ho is always equal to. And your ha is that it's more than 0.5. Okay, so that's our state. I'm gonna go ahead and write a little line. State. What's the next step? Next one is plan. Okay, our plan is we're gonna go ahead and we're going to check our requirements. Okay, so plan. All right, so is this an SRS? Well, if it's taken from the book, I know it doesn't say it. I didn't actually write out the entire problem, but SRS, it is randomly checked. I just took it from the chapter problem from your book. So SRS, yes. And then since this is a proportion, we're gonna test that NP is greater or equal to 5. So we're gonna do NP, which is, our N is 1,009, and our P is 0.5. So really half of 1,009, which is 504.5, which is greater or equal to 5, so we're good to go. And then we're gonna test out NQ, which is 1,009. Well, if P is 0.5, what's Q? Well, it's 1 minus 0.5, which is also 0.5, which is 504.5, which is greater or equal to 5, so they both work out. Okay, so notice I didn't write out, like, I'm just showing that it's an SRS and then that's it. That's our plan part. That's it. Okay, check your requirements is plan. Now let's go ahead and do. Haha, that sounds funny. Do. Now again, you only have to choose one of the options, and I'm gonna go ahead and draw a line right here because I wanna write a sentence at the end and I wanna make sure I have enough space. Okay, so I'm gonna again do it by hand. And then I'm gonna do it by calc. And you only have to do one or the other. Please don't do both. I'm doing both right now so you guys get practice. You get to pick which one you want, or if you want to do both in your notes, but for your homework, I just want one. So by hand, the first thing you want to do is find your z-score. Okay, so if you remember the formula, it's p hat minus p over the square root of square root of p q over n. Okay, so let's go ahead and write out our values. So what was our p hat value? Our p hat value was 0.54 minus our p-value, which was 0.5, over our square root of p, which was 0.5, our q, which is also 0.5, over this n, which is 1,009. And I'm just going to use my calculator to calculate that. So I'm going to do parentheses 0.54 minus 0.5, close my parentheses, divided by square root. And if you're using your old school calculators, make sure you have a double parentheses here. So you're going to do 0.5 times 0.5 over 1,009, and then you would close your parentheses. All right, so you get positive 2.541, and that is your z-score. Okay, now, if you remember from the last section, and that's why I do that last section, is this a right-tailed or left-tailed, or is it a two-tailed? Well, if you're looking at this right here, this is a right-tailed. So you're going to go ahead and you're going to draw a right-tailed test. Okay, so how do I find the percentage? So this is a section, essentially 2.541. We're trying to figure out what is the area in the under the curved region. Okay, so we're going to go ahead and do normal CDF. And then our lower is 2.541. Our upper is 1,000, our mean is 0, and our standard deviation is 1. And I'm going to label that lower, upper, mu, and sigma. And remember, to get to that, you hit second vars, number 2, and then 2.541, 1,000, 0, and 1, and I get 0.0055. And we actually did this example in our last set of notes. This right here is called your p-value. Okay, now that is doing it by hand. Notice you've learned how to do all of this math. Now we're like, what the next part of this thing is to actually examine it. Okay, to do it by calculator, we're gonna do a one prop z-test. And the nice thing is to get to this is the same way to get to all your tests. You hit stat and you go to test. You just have to know which test to do. So one prop z-test. Okay, and then this is what I'm gonna do. As I write out, like type in what I'm doing, I'm gonna write it out, and that's the information that I have to do. So like, for example, p sub 0 is actually what's your null hypothesis? My null hypothesis is 0.5. So I'm gonna write p sub 0 is 0.5. Then I'm gonna write x equals. Remember, x is how many people said no, so it was 545. And our n said 1,009, so I'm just gonna write it out right here. So I'm gonna write 545, 1,009. And then my prop is that it's going to be greater than. Okay, so I'm just gonna write greater than p sub 0. And notice I'm just writing out what I'm typing, because then I know what you're doing. And then I'm just gonna hit calculate, which you don't have to write out because that is it. And then I'm gonna go ahead and write the information that I get. Unless it repeats, then I don't have to, but some of it doesn't. So I'm gonna write z equals 2.55. Okay, and I'm gonna write p equals 0.005. P hat equals 0.54, and then n is already written, so I don't have to write it. But this right here, that is your p-value. And if you look at it, very close. Like this is 0.0056, or 0.06, and this is 0.005. Hence, why I don't make you do it both ways. I would accept one or the other, okay? And then our last statement, which we're gonna go ahead and we're gonna write our sentence. So if we're comparing this to alpha, which is 0.05, is 0.05 smaller or bigger than this? Well, it's smaller. So remember, if your p-value is small, you reject the ho. So I'm gonna write the sentence frame. And again, you should look into the sentence frame. So I'm gonna say p-value is 0.0055. I'm gonna stick with my word. Again, don't write both of them, just write one of them, which is less than or equal to alpha. So reject ho. And then the second part of the sentence, there is sufficient evidence. Sufficient evidence that, and then I'm just gonna go ellipses, but it's the same sentence we did in the end of section 8.1. So I'm gonna write end of section 8.1. Okay, it's the same sentence frame. Okay. So let's go ahead and do another type of example where we're tying in the last chapter and this chapter as well. All right, so it says the claim given in 8.1, example 1, is the majority of consumers are not comfortable with drone deliveries, can be tested with a 0.05 significance level by constructing a 90% confidence interval. So it's asking you, please construct a 90% confidence interval. When we, it's the same example, and we're gonna show that our hoe and the haw can be proved this way as well. Okay, we don't have to do the checks. We don't have to write our hoe and a haw. They're exactly the same as before. But we're gonna go ahead and I'm gonna do this by hand and by calc. And this is from the last section as well. Okay, so by hand and by calc, and then I'm gonna go ahead and leave a little space again to write a little sentence. And I'll write actually a complete sentence this time because it's a little different. All right, so by hand. All right, this is a proportion. So if you think back to the last chapter, it's p hat plus or minus your z star times their square root of pq over n. Okay, now if you use your chart and we're looking at 90% confidence interval, we're gonna be doing, well, p hat is 0.54. We're gonna add and subtract, and if you use your chart from the last section at 90% confidence, this is 1.645 times the square root, and p is 0.5, q is 0.5, and n is 1009. Okay, so I'm gonna go ahead and write my answers out by just adding and subtracting those values. Okay, so I'm gonna do 0.54 plus, and I'm just gonna write out the value. So actually, yeah, 0.54. I'm gonna show you guys a little trick. So 0.54, let's do minus first. Minus 1.645 times square root of parentheses 0.5 times 0.5 divided by 1009. I'm gonna round to 3 decimal places, so I get 0.514, and then I'm gonna do the same thing. I'm just gonna highlight it. It's beautiful if I can highlight it. And then I'm gonna go ahead and change this to a plus sign. And I get 0.566. Cool, that's by calculator. Okay, now here's my question to you. Are both of these more than or less than 0.5? Okay, well, is 0.5 included in it? They're actually not. And so you're gonna think about, okay, so if 0.5 or my null hypothesis is not in here, what do we do? And that's essentially where we're getting at. Okay, let's go ahead and do this by calculator. So if you remember this by calculator, it's 1 prop z interval. And I'm gonna go ahead and go to know what to enter in. So I'm gonna go to stat tests 1 prop z interval. Okay, and then I'm gonna type in what I know. So, oh, that's 2 prop. Okay, so the first thing is, what was your x, which was 545. It already has that, so I'm gonna write that in. X is 545, n is 1009. My confidence level is 0.90 this time. So I'm gonna write CL is 0.90, and I'm gonna go ahead and write out my calculations. Now I already have my n to be here, so I don't have to write it out, but I'm gonna go ahead and write out the confidence interval, which is 0.514 and 0.566. And then I'm going to get p hat is 0.54. Okay, and so if you look at it, guess what, you guys? They're the same answers. Okay, so we're gonna go ahead and just say, like, I'm not gonna use the sentence frame for confidence interval, but I'm gonna go ahead and ask you guys, because I know you guys can do your confidence interval sentence, but I'm gonna ask you a little further question. I'm changing my notes from what I have in my notes, which is weird because I'm just recording. So I'm gonna say, does the interval support 0.5 or greater than 0.5, or like equal 0.5 or greater than 0.5? Okay, so think about it. Does this support 0.5 or greater than 0.5? Well, does 0.5 fall in between here? You're like, no. So then, so far it supports greater than 0.5. Same thing for this one, it's the same problem. So if it's supporting greater than 0.5, are we accepting or are we rejecting the hoe? Well, we're saying the hoe is half, and we're like, no, but both of our answers are greater than our half. So we're actually rejecting our hoe, meaning that we have evidence that the ha is true. Okay, so I'm going to say the interval supports the ha. Okay, since both values in the interval are greater than 0.5, okay, we have evidence to reject hoe. Think about it. We have enough evidence. Now, if 0.5 fell in here, then that would be like, okay, well, if 0.5 fell in here, we can't really reject it. We would have to fail to reject it, meaning accept it. And remember, we never write accept in this class. We always write fail to reject or reject. Okay, so let's go ahead, and I did want you to try a question of like, what happens if I don't give you your x value? Can you solve it? So this one's more of like an algebra question. So it says, a study of sleepwalking or nocturnal wandering was described as Neurology magazine and included the information that 29.2% of 19,136 American adults have sleepwalked. What is the number of adults who have sleepwalked? Okay, so you're given your proportion or your p hat to be 0.292. You're given your n to be 19,136. I want you to tell me what my x is. How many number of adults you do. Now remember, for adults, you always round up because it's people. So your formula is p hat is x over n. And I wrote this in the first page of the set of notes. Okay, so I'm going to go ahead and substitute what I know. So I know p hat is 0.292. Don't know what x is, but I know what n is. N is 19,136. And I said, please solve for x. Well, you should be able to solve for x. You're going to multiply both sides by 19,136. Multiply this by 19,136. Okay, and I already did it. I got x to be 5,587.7. Well, remember, for people, we always want a whole number. So we're gonna write 5,588. So remember, for people, always round up. Okay, so that's your x value. Okay, and the reason why I make you do that is because you guys will be using it for our next example. Okay, let's go on to the next example. All right, example 3. Using the same sleepwalking data from 2, and I wrote it out right here, and I'm gonna write x equals 5,500, forgot the number now, 5,588. We're going to go ahead and answer. It says, would the reporter be justified in stating that fewer than 30% of adults have sleepwalked? Use a 0.05 significance level to test a claim for the adult population. The proportion of those who have sleptwalked is less than 0.3. Okay, so guys, essentially, this is literally what you would be given as a problem, and you would be given like an entire page of blank. And you would have to answer this question, but you have to do every single step. Okay, so let's go ahead and we're gonna again do this slow and steady. So our first part is state. So we're gonna state our variables and what we know. So state is we're gonna let P equal the proportion of, let's see, adults who have sleptwalk or sleepwalked. I think it's sleepwalk. I don't think it's sleptwalk. I thought that was funny. Okay, notice there's no numbers in it. It's just defining the variable. What is my ho? Remember, ho is always an equal sign, so 0.3. And how did I know it was 0.3? Because it said that. It also said 30%, which is 0.3 in a decimal. And then what's our ha? Well, it says fewer than or less than. So if it's less than, our ha is P is less than 0.3. Okay, so think about it. That's a right tail or a left tail? Well, left is left tail. Okay, or less than is left-tailed. Okay, and then it said alpha to be 0.05. That's what it told me right here. Significance level. Cool, I have done everything. I've stated it. Let's go ahead and plan it out. So what does plan essentially mean? Plan means that it says SRS and NP and NQ are greater than or equal to 5. Okay, so let's go ahead and say SRS. Now, it doesn't say SRS, but since the data is pretty big, I wish it said it. I'm going to write SRS question mark. It's okay for that one. I think it says it in the problem. I think I just didn't write it all out, but I'm not sure entirely. SRS, and then we're going to go and check NP, which is our N is 136, and our P, well, I gave you 0.292, but that's not our P. Our P is 0.3. Okay, so that's what our ho deals with. So 0.3, I'm going to go ahead and calculate that. So 19136 times 0.3, which is 5740.8, which is obviously greater or equal to 5. And then same thing, I'm going to do NQ, which is 19,136 times 0.7, I'm just gonna highlight it and multiply it. And I get 13,395.2, which is obviously greater or equal to 5, so they're all met. And that's your plan part. Okay, let's go ahead and do our do. Now again, for your do, I'm gonna do it by hand and by calculator. You don't have to do both, you just have to do one. So by hand, well, if it's a proportion, we use a z-test. So I'm gonna write the z formula. I'm not gonna write out the formula, I'm just gonna do it. But it's p hat, which was 0.292, minus your p, which is 0.3, over the square root of p, which is 0.3, times q, which is 0.7, over your n, which is 9,136. I'm going to go ahead and use my calculator and see what I would get. So I'm going to do parentheses, 0.292, 292 minus 0.3 divided by square root of parentheses 0.3 times 0.7 divided by 19,136. And I get negative 2.415. Okay, and that's your z-score. Now, since this is a left-tailed test, so I'm like drawing a little picture, since we're doing left-tailed, and it says a z-score, we're gonna use normal CDF, and we're gonna say everything to the left of this number. So what's our lower? It's negative 1,000. Our upper is negative 2.415. Our mean is 0, and our standard deviation is 1. I'm gonna say this is lower, upper, mean, and sigma. And I'm gonna go ahead and calculate that. Normal CDF, negative 1,000, negative 2.415, 0 and 1. And that was something I was getting, yes. So I got p-value, because that's the number you're getting, 0.008. Okay, that is by hand. This is our p-value. Okay, we're gonna do this by calculator now. Okay, so by calculator, we're gonna do a 1-prop z-test. So if you don't like, you're like, I'm not ever gonna use the calculator, you can just forward this part. But if you wanna do it by calculator, you can. Or if you wanna skip by hand, either or. Okay, so I'm gonna go back to stat tests, 1-prop z-test, and I'm gonna write out the information I need. So our p sub 0 is now going to be 0.3, because that's what our HO is. Okay, our x is going to be 5588, and I calculated that this way. Okay, so our x is 5588, and if they don't give it to you, that's why you have to calculate it, and you always have to use a number. If you're actually using a decimal in x, it's gonna keep saying error. I found that out the hard way when I taught this for the first time. I didn't really grasp that idea. So 19,136 is your n. Your prop is going to be that it is less than your null. So I'm gonna just write. So again, I just kind of write it and type it at the same time, and I'm gonna go ahead and hit calculate. Okay, so if you hit calculate, you get your z-score to be negative 2.41. I don't have to write 0. Our p-value is 0.008. Our p-hat value is 0.292, which is what essentially we got, and then I already have my n value. But the key idea is this value right here. And if you again look at these two values, they're exactly the same, and so we know we did them right. Okay, so that's our state, our do. Let's go ahead and state, plan, do, conclude. And so write our sentence. Again, I'm gonna write sentence frame. All right, so our sentence frame is the p-value is 0.008, which is less than or equal to alpha, so we reject HO. And I will give you an example where we fail to reject HO, but in this case we reject HO. We're gonna say there is sufficient evidence that there are fewer than, and I'm just gonna write what the HA is, so that there are fewer than 0.3 proportion of adults who have sleptwalk or sleepwalked. I think that's weird. And that is like an example completely through. Like this is literally the entire section of this chapter. Okay, so you're gonna do another one, and I'm gonna have you guys go and pause it and try it out yourself, or if you wanna just keep watching, you can, but this is a good one to practice. I'm just gonna kind of write it all out. I'm not really gonna explain it all the way through. So your state is going to be, well, I guess I am. So let P equal proportion of baby girls using the method. Girls using the method. And if you read the problem, it'll make more sense. Okay? Your ho is that the proportion is 0.75, and your ha is your proportion is greater than 0.75. And it actually makes more sense if you read the problem. So that is your state. Let's go ahead and do our plan. Okay, so it said randomly selected, so we're gonna just say SRS, check, NP is equal to, well, our N is 10, our proportion is 0.75, which is 7.5, which is greater or equal to 5. And then we have NQ, which is 10 times 0.25, which is 2.5, so which is not greater than 5. That's not true. So we're gonna go ahead and talk about what to do, but then we're gonna go ahead and write some other sentence down. So that's our state, our plan, our do, okay? If you're doing this by hand, and I'm not gonna do all of the work, if you're doing this by hand, you're gonna use your z-score formula of p hat minus p over the square root of pq over n, and you're gonna get 0.136, so 0.136. So see if you can get those numbers with the numbers I give you. And if you're doing this by hand or by calculator, you're gonna use one prop z test. And you're gonna, again, describe everything, and you're gonna go ahead and for both of these questions, you're gonna get a p-value of 0.137. Okay, either method, you get the same p-value. Okay, so try it out, see if you can get it. Think about if this is a left-tailed, a right-tailed, or a two-tailed. That'll help with this one right here, but I wanted you guys to try it out yourself. And so I'm gonna write p-value is 0.137, which is actually greater than alpha. So this one we're gonna fail to reject ho. And I'm just reading the sentence frame that I'm gonna write. There is no sufficient evidence that using this method the probability of getting a girl, I'm just writing out the, proportion of getting a baby girl is greater than 0.75. And then here's the one sentence I want you guys to see. Since our calculations didn't come true, I'm gonna go ahead and write, since the requirements were not met, this might be unreliable. This might not be reliable. Okay, like add that if you're thinking, that's really what you know. So if the requirements are not met, just write that sentence at the end, and there I know that you understand that part. Okay, that is the end of section 8.2.